Hello everybody. So my name is Vipin Kumar Yadav and I'm just going to teach you some concepts of the chapter that we are starting with the complex numbers, as you all can see. I'm just dealing with the NCRT NCRT book. Okay. So the concepts I'll be explaining, and those who are studying in a ICSE board and UP board, you can correlate with that. If you have any doubt, you can ask me in comments. I will try to answer all the questions. Let us start without wasting time. See, complex numbers, as I told you already, a number, complex number, I'll denote with Cn. It is a number which has a real part plus I and one more number, real number. Right? But I will call this as imaginary part. Okay. Complex number has two parts. One part is your real part. Real part. It consists of only real numbers. Fine. Real numbers you must be knowing. What are real numbers? Real number contains rational number as well as irrational numbers. So both are real numbers. Now, uh, in this I have second part, which together is known as imaginary part. Now, this part, it has I. I stands for imaginary. So any number which is associated with I right now, here, that number, or you can say that part, will be called as imaginary part of complex number. So imaginary part is IR. Okay, imaginary part is IR. Now this R is also a real number, but this whole thing I will say that this is the imaginary part of the number. So a number which is having a real part and imaginary part is your complex number. Okay, I hope this is understood. Now let's say this is your number and it has two parts. This one part, it's a real part, and the part which is having this I will be called as imaginary part. So this whole number will be called as complex number. I'm denoting complex number with Cn because I'm not going to write complex number again and again. So I'm denoting complex number with Cn. Now here, if I ask you what is real part of this number, real part we denote by Re. Okay, real part of Z. If I say real part of Z, so you'll write like this, real part of Z. Okay, so this is what here, let's say this number is complex number, I'm calling it out as Z. So real part of Z, real part of this Z, so what it will be? It will be 2. Fine. If I say imaginary part of, IM stands for imaginary. Okay, imaginary part of Z, you have to just write this number, you don't have to write this I, because I itself denotes imaginary. So if I say what is the imaginary part of this number, this complex number, you have to just write the number, whatever number is there. So it will be root 3. One thing you need to notice here, you have to just take the sign of this number with it. For example, if I write here 2 minus z, so now this 2 minus iz, root 3, you have to write as a plus ib form. You have to write this in a plus ib form because this is your general form of rational complex number. It is the general form of complex number. So you have to write this number in this form. So if I want to write this number in this form, so how will I write it? Because here this is a complex number, real part of this number is a, imaginary part of this number is b. Fine. So in the same manner I have to write this expression. Okay, so here you can say a is your actually your 2, that is a, I is already there. Now what is b here? Now I need to have plus sign here, but I have here negative sign. So what can I do? I can take negative sign common. So what will be left? Plus. Alright, so when you open this bracket, so this minus into plus will become minus. So this is the other way we can write it down. Now if I compare this complex number with this general form of complex number, then we get to know that real part of this complex number is what? Real part of this complex number is 2. Alright, the number without any I, that will be your 2, real part. Imaginary part, it will be with sign. Plus is there, plus is there. I is there, I is there. So in place of b, what is here? Minus root 3. So this is your imaginary part. So this is the way to identify what a real part of a complex number and what is imaginary part of a complex number. Okay. Let's say I have to add two complex number. Let's say z1 is 3 plus I or 2i, and z2 is 4 plus 7i. So if I have to add these two complex numbers, so for adding these two complex numbers, what I have to do? I have to add their real parts together and their imaginary parts together. So the real parts will be what of z1 and z2? 3 plus 4. Since I am adding, so I am adding their real parts. So real part of z1 is 3 and real part of z2 is 4. So I am just adding these two. So this will give you the real part of z1 plus z2 plus I. Now I have to add the imaginary part of these two complex number. So it will be 2 plus 7. Simplify this, you will get, or it's better to write 9i. Alright, you can write I dot 9 also. So this is the sum of these two rational numbers. Now if you have to find out the difference, again you see, let's say I want to find out z1 minus z2. So here you have to subtract the real part and the imaginary part separately. Okay, so if I write z1 minus z2, it means z1 is 3 and z2 is 2, real part. So 3 minus 4 plus I. The real part, the imaginary part of z1 is 2 minus 7. So it will be minus 1 plus I, and it is coming minus 5. So when you open this bracket, so it will become minus 1 plus into minus will become minus 5i. So this is the subtraction. This is the way to subtract. Okay. Now if I want to find out the multiplication of these two complex numbers, then what do we have to do? Just see. Now if I have to multiply two complex numbers, then you have to just denote it like this: z1 dot z2. So whenever we are multiplying complex numbers, the multiplication is shown by dot. This dot in complex number shows the multiplication. I hope it is clear. So z1 dot z2 means z1 multiplied by z2. So how you are going to do it? We will write the z1 and z2, okay, in the bracket. z1 is 3 plus 2i dot, because it is dot here, dot means multiplication, and z2 is 4 plus 7i. Now we used to do in that for multiplication, we used to do when we used to find out the multiplication of any two algebraic expression or two binomials. That is the same way we have to do here. Okay, so 3, this number will be multiplied by 3, this 4, and again this number will be multiplied by this 7. Okay, so see what will be there: 3 into 4 plus 3 into 7i. Now the 3 is done, 3 is multiplied by both the numbers. Okay, now this 2i will be multiplied by both the numbers. Now this 2i, not 2, 2i, the whole number will be multiplied by 4. So 2i into 4 plus 2i into 7i, 2i into 7i. Clear? Fine. So now we have to solve it further. So it will become 12. It will be plus 21 I. This will be plus 8i. Now this will be 14i square. Now in the starting you must have seen I is what actually? I is root of minus 1. So if I have to find out I square, means if I square both the sides, so what will happen? This square and this square root sign will cancel. So I square is actually what? Minus 1. Okay, so I square is minus 1. So now 12 plus 21i plus 8i, that will be 29i, plus 14, I square is minus 1, as we have seen here directly. So now just multiply 12 plus 29i minus into plus, that will be minus 14. 12 minus 14, that will be minus 2 plus 29i. So if I had to multiply any two complex numbers the same way as we used to multiply two binomials, in the same manner we have to multiply. And one thing you need to see, what is the power of I is coming here, okay, except if power of I is more than 1. So what is the power of I, and accordingly we are going to deal with that. So since it is coming I square, so I square we know that it is minus 1, so we are going to put the value of minus 1 as it is, and then we will solve it. So I hope it is understood how to multiply complex numbers. Now we will see how to divide the complex numbers. Now we have to divide. Let's say I have a question, uh, z2 by z1. I have to divide this. I have to divide complex number z2 by complex number z1. So you have to just understand one concept here. I can write this z2 as, z2 by z1 as z2 into 1 by z1. Yeah, so this is the thing we can do. Just the simple arithmetic concepts that we used here. Let's say 4 by 5, we can write 4 by 5 as 4 into 1 by 5. The same thing we are doing here also. Okay, now it means I have to multiply, the division means I have to multiply this z2 with multiplicative inverse of z1. Can we say like this? If I ask you what is multiplicative inverse of 2, so you will just reciprocal it. The multiplicative inverse of 2 is 1 by 2. If I ask you what is multiplicative inverse of 1 by 2, you will say 2. Okay, so we can say that I have to multiply this z2 complex number with the multiplicative inverse of z1. Okay, multiplicative inverse of z1. So now I have to find out what is this multiplicative inverse of z1. Okay, so I have to first find out z1. 1 by z1 means multiplicative of multiplicative inverse of z1. So we can write this multiplicative inverse of z1 as z1 power minus 1. Okay, fine. All right, let us see how to do it. First I have to find out the multiplicative inverse of z1. Okay, now what is z1? 1 by 3 plus 2i. Now to find out the multiplicative inverse of z1, what I have to do, in your complex number, wherever you see, you have to make sure that the denominator does not have I. You have to make sure that the denominator does not have I. But here the denominator is having this I concept, I component. So I will try to remove this I component by multiplying it by conjugate of it. What is the conjugate of this number, this z1? So if you have to find out the conjugate of any complex number, you have to just change the sign which is in front of I. Change the sign which is in front of I. So here to find out the conjugate of this z1, here it is plus. So what you will do, you will convert this plus into minus. So conjugate of this z1, that is 3 plus 2i, will be what? 3 minus 2i. So whenever you have to remove the I component from the denominator, you have to multiply that denominator by its conjugate. This is one thing you need to remember. Fine. Now the multiplication we have done, how to multiply two complex numbers. Okay, so here in the denominator I have this number as well as this number, so you know how to multiply it. All right, because I have taught you in this the first one how to multiply. So 1 multiplied by this number will give you the same number. All right, now 3 into 3, that will give you 9. 3 into minus 2 I, that will be minus 6i. 2i into plus 3, that will be plus 6i. Plus 2i into minus 2i, that will be minus 4i square. 3 minus 2i upon 9, this will cancel. Now I square is minus 1, we have done it. So minus 1 into minus 4, that will be plus 4. Okay, now can I say this as 3 minus 2i upon this 9 can be written as 3 square, yes or no? Plus this 4 can be written as 2 square. Yeah, I'm just deriving the formula, general formula of inverse of a complex number. So if I assume that this 3 plus 2i is actually a plus bi or ib, this is the complex number. I am just seeing what is the formula for inverse of this complex number. So we can say that, can we say like this? I hope it is visible. We can say like this. I can write 3 by 3 square plus 2 square minus, not minus, plus I minus 2 upon 3 square plus 2 square. We can say like this. Yes. So here you assume that can we just compare this thing with this one? So can I say the conjugate of this any number, the conjugate of any complex number, z inverse or 1 by z, let's say this is z, okay? So can I write this complex number, the inverse of this complex number as, compare from here. So this 3 indicates what? A. So a upon 3 square means a square plus 2 square means 2 is what here? B. So a square plus b square plus I will be written as it is. Now what is this minus 2? 2 is b, so you'll write minus b upon the same thing, a square plus b square. So now you know that the direct formula for finding out the inverse of any complex number is this: a by a square plus b square plus I minus b by a square plus b square. So this is the general formula to find out the inverse of any complex number. Fine. So inverse of this complex number must be clear to you. Alright, I hope so. So this general formula you need to understand, you need to remember it. A by a square plus b square plus I minus b upon a square plus b square. This is the inverse of any complex number z, which is equals to a plus ib. So now I know this is the inverse of z. Fine. So I hope this is clear. Now that we have learned how to find out the inverse of any complex number, we can directly multiply. See here, this z2 is what? 4 plus 7i into complex, or you can say inverse of z1. Inverse of z1 will be what? Now what is a here? 3. So a upon a square is what? 3 square plus b square is what? 2 square plus I upon, now minus, this will be minus b, so 2 is what? B here, so it will be minus 2. The same thing in the denominator. Alright, just simplify it. You will get 4 plus 7i into 3 upon 9 plus 12, 9 plus 4, 13. Now here minus into plus will become minus I, or you can say minus 2i by 13. Okay, similar. So it will be 4 plus 7i. So I'll take this LCM here. It will be, can we write 3 minus 2i. Now here 13 I can take outside, so it will become like this, 1 by 13, and we have 4 plus 7i into 3 minus 2i. Now we know that how to multiply these two complex numbers. Easy. So 1 by 13, so 4 into 3, 12, 4 into minus 2i minus 8i, plus 7i into 3, that will be plus 21i, plus 7i minus 2i, that will be minus 14i square. Okay, so it will be how much? 12, 8i plus minus 8i plus 21. I hope it is visible here. Okay, fine. Now 12 minus 8 plus 21, how much is it? Plus 13, plus 39. Now I square I know it is minus 1, so minus 1 into minus, that will be plus 14. Alright, So this will be how much? 12 plus 14, that will be 26. So ultimately what we are getting, 26 plus 13i upon 13. Can we say like this? 12 plus 14, that will be 26 plus 13i upon 13. We can take 13 out from the numerator. So if I take 13 out, what will be left inside? 2 plus I, and 13 will cancel each other. So the division will give you what? When z2 will be divided by z1, you will get the answer as 2 plus I. So what we have done here, let me recapitulate very fast. z2 by z1 can be written as z2 into 1 by z1. 1 by z1 is the uh, reciprocal, or you can say the inverse of z1. So I know the formula to find out the inverse of any complex number. So directly I have used that formula. So z1 is 3 plus 2i. So a by a square plus b square plus I minus b upon a square plus b square. Solve it. Now this 13 I can write outside. You have this two complex numbers. You know how to multiply. Simplify it and you will get the answer. I hope you have understood how to divide two complex number, how to multiply two complex number, how to subtract, how to add the complex numbers. So the basics we have covered. In that basic, I have told you one concept of how to find out the inverse of a complex number. So rest we will do in the next video. Thank you so much.